Hi, I'm Laura Jude. I'm a civil engineer and I've been working for Buro Happold for 4.5 years.
I want to tell you all about some of the unusual and innovative engineering methods that we implemented when designing a field station in the forest.
The Ankarafa Field Station was a project initiated by Bristol Zoological Society and AEECL, which is the Lemur Conservation Association in Madagascar.
We also worked on this project alongside a few of our close collaborators.
The site is really remote. It's right in the middle of the forest in the Sahamalaza region, which is in northwest Madagascar. So when we traveled to the site to start construction, it took us about 4 days to get there.
Because the site was so remote, traditional construction methods weren't suitable. We also wanted to push for more sustainable alternatives.
After exploring different sustainable construction methods, we came across the interlocking stabilized soil blocks.
These blocks are made using soil sourced close to the site and then stabilized using a small amount of cement and water. The unique shape of the blocks allows them to be slotted together like a puzzle, which also minimizes the amount of mortar required between each layer to form a wall.
So this is first step in making our SSB blocks. We are doing a dry mix which consists of soil and cement. So we're going to see how it goes and hopefully we'll make our first ever block in Madagascar. Stay tuned. Okay, that feels about right. So I think we're ready to make a block now. We've sieved some soil, added about 5% cement and added water and mixed. So we've just reached the optimum water content. So the soil wants to stick to your hand like that, roll into a ball, but if it's too wet then it slips out your fingers, and if it's too dry, cracks form. So this is perfect.
So we're filling the press for the very first time. We close it really slowly, and then open it really slowly. Yeah. Have a look, show the viewers at home. First rock!
Maybe just a little bit more water.
Unlike traditional construction methods, ISSB blocks don't need to be fired. Once they're processed, they're left in the sun to cure, ready for construction. After all the bricks are cured, the exciting part can begin: construction. Another one of our project aims was to improve the sanitation facilities available on site. With no plumbing or drainage infrastructure available, we really had to think outside the box to come up with a sanitation strategy suitable for the site.
So we looked at a couple of different methods and we came across a really interesting technology that uses tiger worms. Provided the right species of worm is available, tiger worm toilets are well suited to most environments, making them a great choice for a site as isolated as ours. All they require is a chamber for the worms to live and the waste to decompose. The chamber consists of multiple layers. The top layer is where the worms sit within a bedding. This is then followed by a couple of drainage layers consisting of graded gravel. The waste sits on top and is decomposed by the worms, and the water filters through the drainage layer and is infiltrated by the ground. After using the toilet, all you need to do is throw down a small amount of water to keep the worms alive, but not too much as to drown the worms. Sustainable development projects have always been what I enjoy and what I'm passionate about, so this has been an amazing opportunity for me. As Buro Happold, we work on a lot of big commercial projects which are really interesting and we're really well known for, but we also get to work on these more community-driven projects, and we have that balance between the two, which I think is very much in line with the company's values.